And my name is Kasper.
And welcome to Engineering Forest.
Welcome all the engineers brothers. Summer is one of the best time to carry out our projects. Everyone usually rests during the holidays, but we hide in the forest to have a peace.
As you may know, the life of an engineer is not easy. We must constantly improve our knowledge, and as a forest engineers we also breed bears. What? Bears. Mustache as well. Sorry. Well, it will take him a bit to become a real forest engineer.
What can I say? Okay. In this and the next few episodes we will present our ideas and projects to realize this summer. We also show you some necessary stuff to carry out these projects. Maybe you will find useful to your work too. All products you can find at farnell.com.
Okay, so actually, today we will deal with the issue of the object movement. Basically, everything in the production process or part of the robot needs to be moved.
Yep.
Imagine a production line, for example our favorite soda. The bottles have to slide on the line, so we need something that will move our products on transmission line.
Yep.
Yes?
Yep.
You know, I have an idea. Follow me, I will show you something.
Okay.
Okay, man. So what do you think about this?
Man, it's too big to put this in the fabric.
What are you talking about? Fine.
Get back to our laboratory.
Okay, so we need something that we can use in the most projects, where we need to make some move, rotating or converting it to linear motion. Electric motors, I think, is the best solution.
Sure.
As it turns out, we have here one electric motor.
Yeah. Definitely smaller than tractor.
Yeah, for sure.
So, the main star of today's episode is an unusual DC motor, because it's a three-phase brushless motor, produced by Trinamic. The power rating is up to 26 watts and maximum speed is 4000 RPMs. It will serve today as an example of a device without the world would not exist.
Exactly.
So, let's keep going with unboxing the stuff. We have here some interesting things that you cannot miss in the lab.
First of all, let's show you the power supply, which is necessary for powering the circuits and our electronic elements. It's manufactured by Tenma, and as you can see we can get 30 volts and 3 amps, yes? 3 amps.
Yeah, why not more?
Who needs more than 3 amps in the forest? We would not able to make second Chernobyl.
Yeah. So, the second thing that helps us work is the oscilloscope, a very useful device to see how our waveforms look like, our currents in the project.
This one is manufactured by Tenma, can measure the signals up to 60 MHz. The ranges given are sufficient for all kinds of measurements in our laboratory. As you can see, it's a two-channel device that doesn't need external power supply, which is crucial when working outdoors. To measure anything, it will be difficult to run with the, with extension cord in the forest with length of few kilometers.
It will be a problem.
The mobile oscilloscope makes our work much easier, and we look even more professional with the suitcase. I think so.
But it's also a multimeter.
As you can see in the app, here we have a connection to probes to measure also the voltage and the currents via those converters.
Yeah. So, let's get back to our motor. To be able to control our motor, we need also a controller. Trinamic, the producer of our motor and the controller, also give us a free access to the controller controlling program. We can download it from the trinamic.com website.
Okay, so the Trinamic Motion Control Language Integrated Development Environment is an integrated development environment used mainly for developing standalone TMCL applications. However, the TMCL IDE also includes a function for using commands in direct mode. Furthermore, it's possible to log data and save it in a CSV files.
Yeah, but we have two control options. Through the computer, as we will present it to you, and through the manual buttons. Bartek, let's tell something about the classical control system.
Okay, so let's move to our beautiful box and see what we have there.
Yep. So here we got a classic contactor. Think that is an inseparable element of every motor. With this one, produced by Schneider Electric, we can close and open main and control circuits. If we do not have enough contacts, we can put this additional block on to extend quantity of our contacts.
Okay, so for control the T on and the T off time, we use timers. Here we have two of them. Let's see first of this. It's analog timer. The specialization and the grabs we can see in the side of it, and it's an 8 pins connector.
Yeah.
This one we use for 24 to 38 volts.
Yeah. See the second one?
Okay, the second one is more classical. I mean, maybe not classical. We can mount it in the DIN rail. It has also 8 modes, and the specialization is also inside of it. From here we can take what we exactly need in the process.
Yeah. Also we have here some terminal block for DIN rail, also by Omron. And they look like this.
For these contactors we just connect our control loops and stuff like that.
Yeah. So today we are dealing with a specialized process. In this case we cannot use these simple elements. We need something more complex and challengeable.
Okay, so here we have our controller. As you thought, maybe it's a size of digital control power supply, but look, it's small thing, small device which one control just our motor.
Yeah, really tiny.
Okay, let's start. Let's try to connect them and see what's going on with this.
We start with connecting our motor and driver to the computer. We will not tell you exactly how to connect the motor to the controller because it's all in the manufacturer datasheet. In our case, we will use built-in Hall sensors which will give a feedback to our process.
Now, something magical is going to happen, because using the program we don't have to be familiar with often boring programming. More or less, we know how to connect the motor and how to power it. But how do we turn it on? With correct speed, or move a transmission line to exact position. To see it, we enter the program, and here we have 3 control modes: turkey mode, velocity mode, position mode. But let's start with wizard pool. We have several options here. To set our motor, we have to connect the Hall sensors like in our picture. After that, we have to go to Hall alignment, and here, let's try. Turn the motor now. Okay. As you can see here, the actual control angle and actual Hall angle, it's crossing. It means that is good for us. Let's try to run our motor at 1000 RPMs. As we can see, our system is fully controllable by using a PID controller. We will see what happens when we put the finger on the shaft. The revolution drops for a while, but return to the set point. Recall our transmission line. When there is more bottles, more resistive force will enter it. Our lines has to move at the constant speed to keep up with the process. Man, this technology is awesome. We made some measurements and we get, for the first look, strange graphs. But let's see. In the channel A, I mean the green one, we have the phase of our motor, and in the channel B, we have the Hall sensor signal. The time T on to T off is changing, and its effect of speed of our motor. Also, we got the red button from Schneider Electric. Casper, remember, do not touch red button.
Okay. It seems to be enough for today. We hope you enjoy it and see you in the next episode.
Goodbye. What did you do?